Okay, let's dive into this. Welcome to today's Explainer, where we're tackling something totally foundational. We're talking about physics. Now look, I know you might hear that word and immediately picture dusty chalkboards or, incredibly complicated math. But today, we're taking a totally different approach. We are looking at physics as the ultimate guide to the stuff you do every single day. It is literally the rule book of the universe. By the time we wrap up here, you're going to be able to completely decode those invisible forces acting on you right at this very second, from the hidden resistance gripping your shoes to the floor to the exact mechanics of your morning commute.
So, let's jump right into Section 1, the rule book for life.
I gotta ask you, wouldn't it be nice to actually read the rule book for life? Well, guess what? It's sitting right there. Literally everything you do, everything you build, even the words coming out of your mouth, it's all governed by a hidden set of rules. This isn't just some theoretical science locked away in a lab somewhere. No, this is deeply, deeply personal to you. It's kind of like the underlying code to the simulation of your daily routine. Take that hot cup of coffee cooling down on your desk. Bam, that's thermodynamics happening in real time. Or the sound waves of my voice traveling through the air and vibrating against your eardrums right now. That's acoustics doing its thing. Physics is an elegant, highly practical, and genuinely fun rulebook that helps you navigate every single day. If you want to understand why your physical reality behaves the exact way it does, well, this is exactly where we start.
Which brings us seamlessly to Section 2, navigating space and time.
Now, what's really interesting here is how these concepts form the absolute basics of understanding your place in physical space. We've got 4 rapid-fire concepts: time, position, velocity, and acceleration. These are the core of daily physics, and figuring out how they all mesh together is absolutely key to understanding motion. Let's ground this in a real-world scenario, okay? Imagine you're just taking a walk down the street. Your position is exactly where you are located on that sidewalk at any given time. As you change your position over a specific amount of time, you create velocity. Boom, you are moving. But wait, suddenly you realize you're late for the bus, so you speed up from a walk to a sprint. That act of speeding up, of changing your velocity, introduces acceleration. So whether you're just trying to catch a bus or you're flying across the globe in an airplane, these 4 variables are constantly interacting to define your reality.
Moving right along to Section 3, forces on everyday objects.
Okay, so we've talked about motion, but now we really need to shift our focus to the unseen forces that dictate how everyday objects actually behave. Sir Isaac Newton famously said, "An object in motion will remain in motion, and an object at rest will remain at rest, unless acted upon by a force." We've all heard it, right? It's an incredibly famous law, but think about how perfectly it demystifies the world around you. It explains exactly why your pen is just sitting calmly on your desk right now instead of floating away or crashing to the floor. It's in a state of rest because the forces acting on it are perfectly, precisely balanced. Gravity is pulling that pen down toward the center of the Earth, sure, but your solid desk is pushing right back up against it with an equal opposing force called the normal force. That invisible tug of war is happening all around you, constantly.
But wait a second, what does that actually mean for acceleration? It's one thing to know an object stays put because forces cancel each other out, or it keeps moving because nothing stops it. But how do forces connect to changing speeds? If we want to understand how you go from walking to running, or how your car goes from 0 to 60, we need specific tools. This is exactly the kind of inquisitive question we need to be asking. To measure changing speeds, we literally have to start measuring the specific forces causing those changes.
And measuring the physical world means answering 2 fundamental questions: how much and which direction. This brings us to a really crucial contrast: vectors versus scalars. A scalar is simply a measurement of magnitude, just the how much. Think of your car's speedometer reading exactly 60 miles per hour. That's a scalar. But to accurately map out forces, we usually need to know the direction too. That is where vectors come to the rescue. A vector gives you both the magnitude and the direction. So, if your car is traveling at 60 miles per hour north, you now have a vector. Understanding this dichotomy is absolutely essential, because the invisible forces pushing and pulling on us every single day always have a specific direction.
Speaking of forces pushing and pulling on us, we have to talk about friction, specifically the difference between kinetic friction and static friction. Pointing out the dichotomy of these specific forces literally reveals the secret to why things move and why they stop. Imagine trying to push a huge, stubborn moving box across your living room floor. When you first push against it, it doesn't budge at all. That intense, immediate resistance keeping it locked in place, that's static friction. It's the force you have to overcome just to get the object to break its state of rest. But once you finally get the box sliding, you might notice it suddenly feels a little easier to push, right? That lesser resistance acting on the moving box is kinetic friction. It is all friction, but it behaves entirely differently depending on whether the object is in motion or sitting completely still.
All right, let's head into Section 4, Meet Your Physics Guide.
To really make sense of all these rules, laws, and invisible forces, you need an expert. So we're taking a look at the Crash Course Physics series, produced in association with our good friends at PBS Digital Studios. Taking the helm is Dr. Shini Somara, and wow, she is incredibly qualified. She's a mechanical engineer, a fluid dynamicist by qualification, and a seasoned TV host of science and tech shows like Techno, Tomorrow's Food, and The Health Show. Originally, Hank Green was slated to host, but he passed the baton specifically because Dr. Samara has these incredible credentials. Her background in engineering is absolutely crucial here. Mechanical engineers are experts at taking highly theoretical physics rules and applying them to everyday, real-world objects. So you are in incredibly capable hands to bridge the gap between abstract math and daily reality.
So, the crucial point here is this. Physics is easy. Or, well, at least as easy as we can make it. I really want to reassure you that while covering materials like AP Physics 1 and 2 might sound super intimidating on the surface, physics absolutely doesn't have to be hard. Why? Because the concepts you're learning aren't actually new to you. These AP-level equations and laws are literally just putting academic vocabulary to the very things your body already intuitively experiences every single day. When you lean into a sharp turn in your car, or when you instinctively push harder to slide a heavy box, you are already doing physics.
Let's move to Section 5 and see how this builds, experiencing a richer universe. We spent time looking really closely at the equations, the forces, and the friction, but now it's time to zoom out a bit. We need to look at the larger, philosophical beauty of learning these rules. Which brings us to this ultimate lingering question. Why is understanding these things so valuable? Beyond just passing an AP test or knowing how fast a car is going, what is the true, life-changing payoff of taking the time to study the physical world? Let's take a moment to really think about that.
The answer is simple but totally profound. It gives you a richer and more immersive experience in life. Understanding exactly how the universe works allows us to see vast, completely unexpected beauty in nature. It turns an ordinary walk outside into a living, breathing masterclass of elegant forces and perfectly balanced rules. When you step onto the sidewalk, you're no longer just walking. You are experiencing the amazing interplay of vectors, velocity, and friction. So, as you wrap up this explainer and go about the rest of your day, I have a challenge for you. Look around and actively try to identify these forces. Notice the static friction keeping your coffee cup on the table, or the velocity of your commute home. What invisible rules of the universe are silently guiding your every move, just waiting for you to truly see them?